Now see this, the necessary and sufficient condition for a square matrix capital A to possess the inverse is that A not equal to 0. It means that if you want a square matrix, see, I have told you that every square matrix doesn't need not have inverse, right? So there will be some square matrices for which inverse might not exist. So this theorem is saying that the necessary condition and the sufficient condition for a matrix capital A to have inverse is that A not equal to 0. So let's verify it. So what do we mean by necessary condition? It means that if a matrix has to be invertible, which means if a matrix has to have an inverse, then it should definitely have det A not equal to 0. That is necessity. Okay. Sufficient means if det A not equal to 0, if we can somehow know that det A is not equal to 0, then it is sufficient to say that that matrix A will have inverse. Let's test both of them. Let's test the condition necessity. Necessity means if A is invertible, then det A equal to 0. This statement, if we can verify it, then we can say that det A is necessity. Det A not equal to 0 is necessity. Are you getting this? I am just testing the necessary condition. What does the necessary condition say? It says that it is necessary for a matrix to be invertible, it should have det A not equal to 0. So my assumption is that if A is invertible, then det A equal to 0, det A not equal to 0. If I can check this, then I can say that it is necessary that if a matrix is invertible, then det A is not equal to 0. Are you understanding it? See, even if you don't understand the theorem, don't worry, just by heart this statement. Okay, you need not understand the proof, but I'm trying my level best to make it clear. Okay, now see this, since capital A is invertible, that is what I have assumed. If A is invertible, then I want to prove that det A is not equal to 0. If capital A is invertible, then there exists capital B such that A into B equal to In. That is clear. If A is invertible, it means that it is supposed to have some other matrix which is inverse in such a way that A into B is equal to In, right? And now take determinant on both sides. Det A into B equal to det In. Then what did we get? Det A into B can be written as det A into det B. And we already know that det In. So determinant of an identity matrix, which is a diagonal matrix, is nothing but 1. Identity matrix is a diagonal matrix in which all the leading principal diagonal elements are 1s. So that is why determinant value is 1. Now if product of two numbers is going to be 1, then definitely those two numbers cannot be zeros. Any of the number cannot be 0. That is why det A is not equal to 0. Got it? So if A is having an inverse, it definitely means that its determinant is not equal to 0. Okay. And next one is sufficient condition. What does sufficient condition say? It is sufficient that if you know that det A is not equal to 0, then you can declare that it is having an inverse. That is sufficient condition, right? So if det A is not equal to 0, then A will be invertible. This is a sufficient condition. Let's check this. Let us assume that if det A is not equal to 0. If det A is not equal to 0, then from A we can form a new matrix B in such a way that B equal to adjoint A divided by det A. Can we form this? Yes, of course. The reason is adjoint A will exist for every square matrix, and since we are saying that det A is not equal to 0, definitely we can divide it with det A, isn't it? The reason is it is not equal to 0. In case if det A equal to 0, we cannot form it. Otherwise we can form it, because adjoint of A exists for every square matrix irrespective of what it is. Adjoint A exists for every matrix, and then det A here I am saying that is not equal to 0, therefore it is definitely possible, right? And after forming such a matrix B, then you check this, A into B, then A into B equal to A into, I am just substituting that particular B here. Okay, then what did we get? A into adjoint of A divided by det A. Then we already know that A into adjoint of A, we already know this, we have already seen that A into adjoint of A equal to adjoint A into A equal to det A into In. We already seen it in the earlier theorem. Please revisit that theorem again. If you don't remember, just watch it here. A into adjoint A, product of these two matrices is going to give us det A into In, and already det A is here, so cancel out those two, then we are going to get in. And similarly here, b into a equal to, in place of b I am substituting whatever we formed there, and again we got edge a into a divided by det A, and we know that adjoint a into a, adjoint of a into a is nothing but det A into in. Now again you cancel them out, we get in. Therefore we got a into b equal to in and b into a equal to in, therefore ab and ba both are equal to in. And so for A, for the matrix A, there exists a matrix B which is inverse of A. Therefore, if det A is not equal to 0, then the matrix can be inverted. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.